Hola, buenas tardes amigos, bienvenidos a esta, la primera, segunda, tercera, la cuarta charla de este diálogo de astronomía. Y como en cada uno de los 5 invitados que nos estarán acompañando a lo largo de este ciclo, hoy también es un honor para nosotros recibir, estamos platicando de un rockstar a nivel mundial. Es para mí un honor recibirlo y déjenme platicarles poquito acerca de él. Dr. Chris Packham es graduado de Física Aplicada y doctorado en Astrofísica por la Universidad de Hertfordshire y también por la Universidad de Cambridge. Actualmente él es investigador asociado de la NASA para el desarrollo de telescopios en la gama infrarroja. Su investigación es acerca de los agujeros negros supermasivos en galaxias externas, los discos protoplanetarios alrededor de las estrellas y el desarrollo de instrumental infrarrojo para los telescopios de esta franja de luz. Actualmente lidera un equipo también internacional de investigadores para el desarrollo de telescopios de nueva generación, precisamente para el estudio de agujeros negros supermasivos y su relación con la creación de las galaxias. Por favor, acompáñenme a recibir Chris Packham. We are quite honored to have you here. Thank you very much for accepting this invitation.
Muchísimas gracias a todo el mundo. Estoy muy contento hablando con ustedes. Esta cosa es muy importante, entonces estoy en la Universidad de Texas en San Antonio, pero muy contento para hablando con ustedes en México. Entonces, muchas gracias.
Agradecemos mucho el esfuerzo. Chris no habla ni un ápice de español. Agradecemos mucho el esfuerzo que acaba de hacer. Y precisamente tuvo la cortesía de compartirnos su charla con subtítulos en español para que pueda ser aprovechada por toda nuestra audiencia. Ahora
Muy bien.
3, 2.
Hello, my name is Professor Chris Packham. I'm a professor here at University of Texas, San Antonio. I'm actually from the United Kingdom, from pretty close to London, and I've had a chance to live and work throughout my astronomical career in London, Tokyo, Spain, and now in the United States. So let's get across and take a look at some of the very cool things that I think are going on in astronomy right now, and talk about the telescopes we use and how I think we can go out and look for life on other planets. Let's take a look at those slides. So I termed this presentation about new frontiers of astronomy. So let's talk about where I think 2 of the most exciting frontiers are. Again, Chris Packham, University of Texas, San Antonio. I also hold a position still at the National Astronomical Observatory of Japan. So what I'd like to talk about is astronomy and telescopes, then talk about how many planets there might be out there, how often do you think that we could actually find life, how we'll actually find that life, and in about 45 minutes from now, talk about some final conclusions. So, telescopes. Telescopes are the fundamental tool of the astronomer. For astronomers, the most important thing is to collect as many of those precious photons as possible. So absolutely fundamental to astronomers is to have the largest telescope size available as possible. Now, Galileo was the first person to use a kind of ship's telescope, and I've got an artist's impression of Galileo here, looking through a kind of ship's telescope, making observations perhaps of Jupiter and those famous moons that he looked at, or perhaps at the moon that he also began to really understand what was going on. Now, nowadays, we no longer look through a telescope, very sadly, and the reason is our eye only collects about 1% of all of the light that falls onto it, about 10% for the best photographic emulsion, the old-fashioned cameras that we used to use, but modern-day cameras, modern-day electronics can collect about 99% or more of all of the photons that fall onto that camera. So it's much, much more efficient to use a camera, just like we have in our Androids or our iPhones, to collect those photons and look at those very faint objects that are often very, very distant away from us. So sadly, some of the romance has gone out of astronomy in that we never look through telescopes anymore. And also, we no longer use the type of telescopes that Galileo was first used. So what we now use is telescopes that are like this image here. This image in the top right-hand side, the light comes in from the star, hits this so-called primary mirror, hits a secondary mirror, and then goes up into the eyepiece or the camera. This type of telescope, the one I'm circling now, this is the one that we used, that Galileo used. This is the more traditional type telescope, and indeed the ones you might see in kind of high street stores. This type of telescope, this is the one that most astronomers use, and the ones that you can find at the more expensive stores. So if you want to get a really good telescope, this is the right telescope to go out and target if you can. And indeed, here's a couple of pictures of a telescope called Gemini. Gemini is the National Science Foundation in the United States, the flagship telescopes, and these use a very large mirror. So behind this blue area, this is where we have the primary mirror. So the light comes in, hits this primary mirror, hits the secondary mirror, and then actually goes in through a hole in the back. And here we have a whole series of cameras that can collect the light and analyze the light. We can look at the various colors of the light there with a very, very high fidelity, try to analyze and understand what's going on, or we can make those beautiful pictures that we're used to. So this telescope, this mirror is about 8.1 meters in diameter. It's a pretty large mirror. This is one of the largest telescopes in the world. This one here with an X in it, this one is actually over in Hawaii. It's a beautiful site. You can see this was taken at sunset. You can see the beautiful colors of the sky here. This one that I'm going to write Gemini South, GS. This one is a picture that I took over in Chile. And here you can see the telescope. This is the secondary mirror, as I'm showing here, the secondary mirror there. And you can see the rest of the telescope just here inside that structure. And we have this opening here so that we can see any part of the sky. And this whole dome can rotate to allow us to see any part of the sky that we want to look at. I always think it's important to note here, these things are huge. These things are absolutely enormous. Look at the door here, so you can get an idea of the scale of how big this telescope is. But pretty cool to go out and use them and have a chance to look at distant objects using that telescope. Now, actually, it's interesting. There is a Canary Islands connection to, of course, Mexico and San Antonio. And that partially came in San Antonio because in March of 1730, various families from the Canary Islands came to so-called Nueva España. As they sailed across the ocean, they used the stars to help be guided there using something called an astrolabe. It took about 1 year to come across. They actually landed in Veracruz and then moved northwards, and they helped to found San Antonio. Now, one of the nicest things is that the island of La Palma in Las Islas Canarias has the world's largest telescope, the Gran Telescopio Canarias. And it's a wonderful telescope. It is actually, again, the world's largest. It has a mirror of about 10.4 meters across. This is what it looks like. This is a professional photograph. And here we see, of course, the dome, the telescope inside there, the beautiful Milky Way Galaxy here. The ocean, you can see, is well below the telescope, of course. It's on a very, very steep mountain over in La Palma. Here's a few pictures that I took last time I was over there. It's a tremendous site. It's a tremendous location, I mean. So here, this image here. This is looking out of the telescope, and you can look down onto the clouds. The ocean is very far below there. just tremendous. Another image of the volcanic caldera, and again, the clouds over here looking straight down on them. I went up to the very top of the peak, and you can see the telescope just inside here. This is getting prepared to go out and use it to make observations for that night. And if you face one side, you can see the Gran Telescopio Canarias. If you look at the other side, you can see the other side of the mountain. This is called abbreviated to what used to be called the English side, as the English had their big telescopes here, including this one. This is the William Herschel telescope. At the time, this was the largest telescope in Europe, has a mirror 4.2 meters across. And I had the privilege and honor to use that telescope and indeed run that telescope for a few years that I was living out there. Just as an aside, this is the caldera. This is an extinct old volcano on La Palma, and as you may have seen in the news very recently, the volcano in La Palma is erupting and producing a large amount of new land, and luckily the area for the volcanic eruption is far away from the telescopes, so no danger, at least as I record this, to the telescopes, but incredible to think that there's an eruption going on my old home island. So let's see, why do I talk about the importance of telescopes so much? Well, here I'm showing a couple of pictures of the same galaxy. This is called M51, the Whirlpool Galaxy. This image here, the one that I'm highlighting in yellow, this is actually a hand drawing of the galaxy. And many years ago, people didn't know if there was only one galaxy, the Milky Way Galaxy, or if there were thousands. People simply couldn't believe that the universe would be so big as to have so many thousands of galaxies. This is taken using, this image was drawn by hand. This is taken by one of these electronic cameras that collects 99 times more light per second than we can with our eye. So why is this so important? Well, if we look at the progression from 1 meter to 2 meter, 4 to 8 meter type telescopes, it's fundamentally changed our view of the universe. 2 meter telescopes found that these so-called spiral nebula were not nebula. These were galaxies. These were very, very far away galaxies. It took the 2 meters to start to see those spiral nebula. It took the 4 meters by a guy called Edwin Hubble to prove that these were actually galaxies far away from our own galaxy. 8 meter telescopes found actually that those galaxies are not only very distant, they're moving away from us at ever accelerating rates, and gave rise to this mysterious thing called dark energy. This is the subject of a talk in itself. I don't have a chance to get into this at any level, but it's just thrilling to think about this thing called dark energy. Probably changes the fate of the universe. So my point is, as we've moved to these larger telescopes from 1 through to 8 meters, we see things with a greater level of finesse. And it changes not only astronomers' view of the universe, it actually has a very strong impact into society. To understand, in Galileo's time, for example, we thought that the Earth was the center of the universe. Nowadays, we know we're just one galaxy, one planet in orbit around one star in one galaxy amongst thousands upon thousands of galaxies out there in the universe. It really is an important impact into society to understand our place in the universe that only having these bigger telescopes can allow us to really unlock. So if we put all this together, we can think about how it would look like if we took an idea of the so-called Big Bang, which is up here, to where we are now. We can make this image of the history of the universe. This is a complete representation of the story of our very own universe. Again, I don't have time to talk about this. I just want to say one thing that I always find the most beautiful thing when I think about our role in the universe. At the time of the Big Bang, the only elements that were in the universe were hydrogen and helium. Of course, you and I are made up of carbon, nitrogen, oxygen, and many other elements. The only way we can produce those elements is by stars undergoing nuclear fusion to change those elements all the way up to iron. And then if we want to have heavier elements such as gold or platinum, we need things such as supernova to make up those heavier elements. One of the most beautiful things that I've heard, and it's partially inspired me into astronomy, is a guy called Carl Sagan, who's sadly no longer with us. He famously said, "We are all made of star stuff." Just an incredible way to think of our connection at a very deep and very personal level to the universe around us. Now, one of the questions that I want to address is, are Earth-like planets rare or are they very common? Well, back in 1995, we only knew of 8 planets, the 8 planets of our own solar system. Today, we've got over 4,400 planets known, and indeed we can watch them in orbit. Here, this image in the top right, I've kind of magicked away the star, or rather other people have magicked away the star, and we see 1, 2, 3 planets in orbit around this star. This was a staggering image when it was produced. Absolutely thrilling to see those planets are actually in orbit around that stars. Nowadays, we can say how many stars there are. We think that the numbers would be in the 17 billion in our own Milky Way Galaxy alone. This is incredible. If you want to, you can go out and take a look. This is a live image of the Exoplanet Archive from the California Institute of Technology. You can see actually they've found a couple more planets since I last spoke, 4,516. You can click on that and you can get an idea of the information that we have on these planets. This is just incredible that we can see this huge number of planets. We can see all their information here. Just thrilling to think that we can do this using the internet, using the tools that astronomers have access to. So it's a really cool time to be in astronomy. I want to show you one other picture that's actually born from this one, but it's taken with more recent observations. This is a real image. Again, we've magicked away the star. Here you can see 1, 2, 3, 4 planets. We can watch them in rotation, in their orbits around that star. What a thrilling time that we can see this directly with the telescopes that we have access to. You can see here the timer ticking up, so we have to watch over several years in order to detect their motion, but wow, how cool is that? So one of the other things that I think is amazing, we've done a lot of work in this area, but actually here's a representation of the Milky Way Galaxy. Here's our own sun. This is the area that we've actually managed to survey, just this small little area here. We've got a lot more work to do. Of course, it gets harder. The further that we want to look away from the Earth, the harder it gets. But wow, what an amazing time to be thinking about doing this kind of work. Now, it's interesting having planets, but what we want to have is planets that could potentially host life. And it turns out that if you're in the center of the galaxy here, this may not be so hospitable to having planets that could host life. Because there's too many stars there, it would be difficult to maintain a stable orbit for a long time. In the outer regions of the Milky Way Galaxy, for example, it may not have enough time to produce those elements that we need for life, or that we think we need for life, because there hasn't been enough supernova explosions. So colored in green, and I'm circling it in yellow, is perhaps the best area that we could search for life and planets that would be able to host life. Perhaps there's a galactic habitable zone that would be the optimal place. Of course, we live over in this kind of area, so we're just on that outer edge of where it's good to kind of hang out and be on a planet which has the right makeup of elements to allow us to make life. So we know kind of where to look, we kind of know how to look. Let's think about, could there be life there? Let's ask two questions. How many civilizations could there be out there? And how could we search for it using something called SETI? SETI is the search for extraterrestrial intelligence. So let's talk about these two questions. Well, there was a guy called Drake who decided that he wanted to try to estimate how many civilizations there were outside of our own solar system. He came up with the Drake equation. He said the number of civilizations with whom we could potentially communicate is this very simple equation. He said the number of habitable planets in a galaxy, multiply by the fraction that have life, multiply the fractions that evolve into civilized life, multiplied by the fraction that there are now. And this is a very simple equation. We can now answer this. We know how many habitable planets there are out there, at least within our own part of the galaxy, and then we can assume there's nothing special about our own part and then estimate how many planets there are within our Milky Way Galaxy, 17 billion Earth-like planets. The tough thing is here. How prevalent is life? How prevalent is evolution into civilized societies? And how many of them have survived challenges such as wars or perhaps climate change? We have no idea of that, of course. But we're starting off with a very big number. NHP is a very big number, probably billions. So we don't need many to actually have life evolve and maintain that evolved life to think that there's a large galactic civilization out there. So for my own interest, I want to ask you a question here. This is a picture of me sitting on a very famous person's lap called Dr. Einstein, I should say. He pondered this question a lot. He said, is there intelligent life out there? I'm going to ask you this question. What do you think? Do you think there's intelligent aliens out there? It's just a yes or no answer. I'll give you a few seconds to think about that answer yourself. And why don't you tell your neighbor what you think and exchange information? Okay, and if you're interested, my thoughts, is there intelligent aliens out there? Absolutely. I can't wait to meet them. I very much hope we all get a chance to meet them, but I'm not holding my breath. So how does SETI work? How are we going to find this extraterrestrial life? Well, SETI experiments look for a deliberate signature from extraterrestrial intelligence. How does it do this? Well, one way, and I'm showing it here, is that they listen to the radio wavelengths, and we listen to see if anybody is broadcasting any signature, any sign from their host planet to us. In fact, we've sent a signal about ourselves to the stars. We sent it to a globular cluster, a collection of an enormous number of stars called M13. The problem is, in order to get an answer, we have to wait 42,000 years because it's so distant in order to be able to, for the speed of light to get to there, be interpreted, and for that information to come back. So it's a long time to hear from us. So this is the message we sent. This is showing the Arecibo Observatory. We are the third rock from the sun. Humans, we have DNA, and there's some other decoding information here to help make the message clear. So not a very high resolution graphic here, but it's just a kind of way to say we're here. Please come and talk to us. So one of the ways that we'll actually be able to discover life on other planets is by looking at observations, very sensitive observations from this next generation of 30-meter telescopes. So what do I mean by this? Let me show you a quick video, which I find just beautiful to see what we're envisioning for these next generation of telescopes. All right, so that was a video about the 30-meter telescope. So I'm actually leading an infrared instrument that I hope will be selected for an opportunity to be used on the telescope. And what I'd like to think about looking for the building blocks of planets and biological materials. In order to do this, I need to work, of course, with my colleagues in the USA, in Japan, Canada, India, and China, and of course, their respective funding agencies to enable this to occur. So what will I be planning to do? I want to look at exoplanets. So how do we find exoplanets? An exoplanet is a planet that's around a different star. So that immediately makes them very, very hard to see. Although we've seen a few, like the images I showed you earlier, they're still pretty tough to see. Now, there's two very successful methods. Transit, and I'm going to talk about radial velocity next, but transit, we search for the shadow. So let me show you what I'm trying to say here. Let's imagine we have this planet in orbit around a star. Here we've got a nice star. We can see it rotating there. Keep an eye on this graph. What you can see is the light from the star is constant. Then when the planet moves in front of it, it hides some of the starlight. We see this beautiful dip here, and that allows us to infer the presence of that star. Of the planet. We don't have to see the planet because it's very, very faint. But we can see the light that's blocked out by that planet as it moves across the surface of that star, or as we see at the surface of the star. Very, very useful technique, very, very effective way to find planets. Another way we can think about it is this so-called radial velocity. When we have a planet in orbit around the star, the planet actually makes the star move slightly. It pulls it by its own gravity. If we look very carefully at the light, some of the light gets bunched up depending upon the position of the planet and star in its orbit. Some get stretched out. It's very similar to the speed estimations that police use using radar. By looking at the wavelength of light And seeing this period changing because of the period of the planet in orbit, we can get a very good idea of the presence of the planet, and we can infer the mass of the planet there. So these are two very, very useful techniques in order to search for the presence of planets and indeed to get an understanding of the mass of those planets. Now, the next thing that we can do that started to be done here from Earth is to think about looking at their atmospheres. So here, let's start on this lower planet. So this planet here, what I'm showing is it doesn't have an atmosphere. So the starlight in a transit is either blocked by the planet and then we can detect the transit, or it just passes above the surface and we just see the standard color of the star over here. Nothing special going on. In this case, some of the starlight is blocked out by a transit, but some of it goes through this very, very thin atmosphere of this planet. The atmosphere of this planet filters the light, and by looking very carefully at the filtering and the colors of that filtering, we can get an idea of what is in the atmosphere of this planet. This is a way to smell or sniff their atmosphere. So in this way, if we can use this using those very large telescopes, we can get an idea of what's in the atmosphere of these very distant planets. This is what I think we can go out and do to understand the atmospheres of these distant exoplanets, and also to understand if there's indications of the presence of biological life out there. This is so exciting. So in the United States, we have two big telescopes that are being envisioned. This one is the Giant Magellan Telescope. You can see it's got 1, 2, 3, 4, 5, 6, 7 8-meter mirrors all put together. The light comes off this primary, hits the secondary, and goes through the hole there, and that's where we put our cameras. Or the 30-meter telescope, which is the video I showed you earlier. I'm really hoping that these two telescopes will enter operation in about 10 or 15 years away from now. So we've got a lot of work to do to build these telescopes and to make this preparations, but it's an incredibly exciting time to be using high technology to do some of this really cool science. So, in my opinion, the future's really bright. I'm really hoping to build an advanced infrared instrument for the TMT and try to understand exoplanets, their atmospheres and formation. I think it's a thrilling future. We need to have the entire world collaborating to understand one of humankind's greatest questions. Are we alone in the universe? And I love this quote from a very famous science fiction writer called Arthur C. Clarke. He said there's only two possibilities exist. Either we're alone in the universe or we are not. Both are equally terrifying. For me, it's way more fun if there's the aliens out there. I hope we'll get a chance to begin to discover how prevalent life is on other planets. So with that, I'd love to take some of your questions. Thank you so much for listening.
Thank you very much indeed. Muchas gracias a todos por seguir escuchándonos. Y ya estuvieron llegando algunos. Tú avisaste en San Antonio que ibas a estar aquí en México en la charla. Have you mentioned to your friends in San Antonio that you were about to be here? Because so far, you have greetings from Magdalena, Cynthia, Abelardo Delgadillo says hi. Carlos de Jesus says, what a pleasure. Mireya Espinosa also says hi. Liz Montaño, Saraí Robles, Miguel Pérez, and Daniel Orozco. Everybody of them sent their greetings to you. And we also have some questions. También tenemos algunas preguntas del público que nos está llegando de diferentes...
Muy bien.
Ok. Y la primera nos dice, mira, es de Valentina Rodríguez y nos dice, ¿por qué estudiar astronomía? Why would we choose to study astronomy?
So in English, I chose to study astronomy because I always wanted to understand why are the stars there? Is there life on other planets? How do black holes work? So those are the reasons for me to study. I'll let you translate.
Ok, Chris nos dice que él estudió astronomía porque él siempre se preguntó ¿cómo sería llegar a las estrellas y si es que existe vida más allá de nuestro planeta? Fueron las razones que a él los llevaron para elegir esta carrera. Wonderful, thank you. We have another question from Ricardo. Tenemos otra pregunta de Ricardo y él nos pregunta, ¿qué crees que suceda primero? Esto es muy interesante, debe ser un estudiante seguramente. ¿Qué crees que suceda primero? ¿Que se encuentren microbios en Marte o que haya colonias humanas en Marte? What do you think we're going to face on first? Microbes on Mars or human habitats on Mars?
I think we will find microbes on Mars first. We have a probe, NASA's latest probe actually took some Mars rock and put it into a container ready to be sent to Earth. So I'm hoping that we can get Mars rock here in the not too distant future.
Chris nos menciona que él considera que primero se van a encontrar microbios en Marte y esto debido a que actualmente hay una sonda ahí que está facultada para tomar rocas y enviar esa información a la Tierra para ser analizada. Thank you very much. We also have a third question from someone whose name is Carol81, de alguien que se hace llamar Carol81 y pregunta, es muy interesante, ¿existe el planeta 9 en el sistema solar? Is there a ninth planet as the solar system?
Well, in science, we can never prove there is not something. We can only prove that there is. So the only thing I can say, if there is a ninth planet, it must be very distant or not very massive because we cannot see it and we cannot detect the gravity from it. So if there is a ninth planet, it's not a very significant body.
Thank you very much. A ver, la respuesta de Chris es muy interesante. Él menciona que en la ciencia solo se puede probar lo que exista. Entonces, si es que existiese un planeta 9, o es muy pequeño en masa, o es muy, muy alejado y por eso aún no ha sido captado. Thank you very much, Chris. We also have a fourth question, and this one comes from María Elena. Tenemos otra pregunta de María Elena y nos pregunta, ¿en qué lugar crees que sería más probable vivir? ¿Marte o la Luna? In which place do you think we have more chances to live as humans? Mars or the Moon?
I think probably, that's a really good question. So I think to make life on Mars, we would have to have a moon base because it's easier to move things to the moon and then continue on to Mars. So I think the answer's both in that way, but I'm going to change your question slightly. That when we think about going to other moons, that's really exciting. So maybe the moons around Jupiter or around Saturn, that's a long way off, but we need to colonize the moon first, then Mars, then on to the rest of the solar system.
Thank you very much. La respuesta de Chris es muy interesante. Él menciona que antes de que haya un hábitat en la Luna, en Marte, seguramente antes ya habrá un hábitat humano en la Luna. Pero incluso él cambia la pregunta y más bien la proyecta a algo más interesante todavía. Hacer exploración de lunas de otros planetas, principalmente hablando de algunas de Júpiter. Thank you very much. And at least so far we have a last question. Well, actually it's not a question. Al último tenemos lo que parece ser una pregunta, pero en realidad más bien nos está pidiendo si podrías compartirnos títulos de algunos libros para niños acerca de planetas y exoplanetas. I believe this one is from a father and he's asking your suggestion for some books for child about planets and exoplanets. So if you could please send us something like that, you don't have to send it today. I mean, we may attach this to your talk. Si en dado caso que no cuentes ahorita con los títulos para estos libros infantiles, nos puedes enviar tus sugerencias y nosotros con mucho gusto las pondríamos debajo de tu charla en esta participación.
There is a wonderful new book that has just been released by NASA that discusses an astronaut going to space, a female Hispanic astronaut going to space. The book is in English.
This is huge. Chris está diciendo que acaba de salir un nuevo libro editado por NASA acerca de una astronauta mujer hispana. And then?
She's in space and doing science explorations. This is in English and Spanish, and it has augmented reality in it.
Menciona que el personaje, que es la astronauta, se encuentra en el espacio haciendo exploración y el libro está en español y en inglés y cuenta con realidad aumentada.
I'm looking for the book now on my other side. So I'm going to put it in the chat box to you now. It's a really cool book. Highly recommend it.
Ok, nos dice Chris que él nos va a poner el título del libro para nosotros compartírselo después y están llegando nuevas preguntas. Chris, as we speak, there are some new questions and someone is asking, do you really think there is life out of planet Earth? Alguien nos pregunta, ¿realmente creen que haya vida fuera del planeta Tierra?
There's an easy way to answer that. Imagine all of the beaches everywhere on the planet Earth. Imagine how many grains of sand there are. We have already seen more stars than all of those grains of sand on every beach on the Earth.
Okay. Caray, esta respuesta está, a ver, Chris nos menciona, pensábamos que había tanta cantidad de estrellas como granos de arena en el desierto. Al día de hoy ya se han observado mayor cantidad de estrellas como arena en el desierto. Imagina que tal vez en alguna de ellas existiera vida y esto serían las probabilidades que ellos existen. Thank you very much, Chris. There is also, this question looks from someone who has studied something about astronomy. Esta pregunta parece venir de un estudiante de astronomía y menciona, para detectar un exoplaneta, in order to find an exoplanet, necesitamos estar en el mismo plano de manera paralela. We need to be in the same plane in order to have a side view of it. La estrella lejana, el exoplaneta y luego nosotros. The four stars, the four star, the exoplanet, and then us. Ahora bien, no es posible que haya planetas que tengan una órbita perpendicular a la nuestra y por tanto no podamos detectarlos. Is there a chance for an exoplanet to have a perpendicular orbit according to ours, and then we have no chance to detect them?
So great question. With very sensitive telescopes and instruments, like the image I showed with the 4 planets in orbit, those are actually perpendicular, but we can only do that for a small number of planets. We need those big new telescopes to pursue the answer to that question.
Okay. Even if they are perpendicular.
Yes.
Wow. Okay. A ver, esta respuesta está tremenda. Nos menciona el doctor Packham que con telescopios suficientemente poderosos, así como el ejemplo que nos compartió en que hay 4 planetas orbitando a una estrella, que de hecho se encuentran en un plano perpendicular a nosotros, con telescopios con suficiente poder se podrían aún detectar la existencia de esos planetas, aun cuando se encuentren perpendiculares a nuestra perspectiva. Great question. Gracias por la pregunta. Una pregunta muy interesante. Thanks for the question. It's quite interesting. And thank you, Dr. Packham, for the answer. Gracias, Dr. Packham, por la respuesta. Estoy seguro que llegarán algunas más y se las haremos llegar al Dr. Packham.
No, está bien. Más está bien. What? Tengo tiempo si quieres más preguntas.
I mean in the long of the afternoon, but yes, we have time for okay, no, not the last one, sorry. There are 7 more questions. Sorry about this. Okay, no, I already, that question was from Mireya Espinosa. Gracias, Mireya Espinosa, muy interesante tu pregunta. Now there is another one. ¿Cuál es tu máxima aspiración en el campo de la astronomía? What is your highest goal in the astronomy?
I think there's two main questions. Firstly, how did the universe start from the Big Bang in...
De primero nos menciona, es que no soy profesional en esto, de primero nos menciona el doctor Packham que detectar cómo fue el universo, cómo se creó el universo.
And the second is there life on other planets?
La segunda es si existe vida en otro planeta. Por cierto, la pregunta de la perspectiva perpendicular, una pregunta muy interesante, viene de Carlos de Jesús. Un saludo a Carlos de Jesús. The question about the perpendicular orbits comes from Carlos de Jesús. So we sent greetings to him. Tenemos otra pregunta. Ok, esta es muy interesante. Viene de Mireia Espinosa. This comes from Mireia Espinosa and ella nos menciona, la Semana Mundial del Espacio se dedica a las mujeres en el espacio. ¿Qué opinión tiene respecto a la incursión de las mujeres en la carrera espacial? Given the fact that the Space Week is about women in space, what is your opinion about women in this field?
We need to encourage more women into astronomy. We need more female astronauts. And so I think it's very exciting. One of NASA's first goals in going back to the moon is the first woman on the moon. The chance is happening now.
Okay, el doctor Chris nos menciona que es necesario fomentar precisamente la incursión de las mujeres en la astronomía, en la exploración espacial, y que actualmente uno de los objetivos de NASA es precisamente llevar a la primer mujer a la luna. Thank you.
And the book that I sent is called The First Woman.
Ok, el libro que nos compartió, que nos recomienda el doctor Chris Packham para lectura de los niños en casa es precisamente La Primer Mujer. Tenemos otra. We have another one. We really have another one. I mean, you may read them from the chat.
Sure.
Podrías leer del chat. Dice, ok. Bueno, tenemos una pregunta y nos dice, si descubres vida en otro planeta, ¿te irías a vivir hacia allá? In case you find life in a different planet, would you take a trip to there?
No sé, porque mi vida aquí en San Antonio está bien y posiblemente la vida ahí son peligrosos. Entonces no sé.
Ok, creo que no es necesario traducir eso, fue muy claro. Interesante. Y bueno, pues queremos agradecer mucho a las personas que nos han seguido en esta charla y también en las charlas anteriores. Y por supuesto los invitamos a seguir con nosotros. Mañana vamos a continuar precisamente en esta misma temática con Norberto Álvarez, quien fuera capitán de misión de Biosfera 2, que tenía uno de los objetivos era precisamente ser el primer prototipo de hábitat humano para ubicarlo en el planeta Marte. ¿Qué sabemos de qué se necesita para que una biosfera existe y qué no sabemos aún para hacer posible precisamente este camino? Chris, I'm inviting the audience to join us tomorrow in the talk about Biosphere 2, which was, as you know, a prototype for human habitats on Mars.
Sí.
What do you know about the biospheres and what we don't know yet about them in order to make this dream to become quite possible, okay? Gracias, Chris. Gracias a todos quienes nos están haciendo el honor de acompañarnos. Y recuerden, aún también vamos a tener otra charla la siguiente semana, el jueves. Nos va a acompañar Kelly Petty, editor de la revista Sky and Telescope, tal vez la revista más importante de astronomía en el mundo. Nos va a platicar precisamente sobre el planeta Marte. Remember, next Thursday, we're going to have the talk from Kelly Petty, editor from Sky and Telescope, who's going to talk about Mars indeed. Chris, gracias. Ha sido un honor tenerte a ti. Chris, thank you very much.
Gracias a ti.
Luego a todo el público.
Muchas gracias todo el mundo. Gracias. Bueno.